All right, welcome to our Thursday evening weather chat discussion session. And tonight, we've got Kempton Izuno is going to lead our weather analysis, and he's going to give us his tips and tricks on the use of Pivotal, sort of walking us through his steps on how he does his analysis. And we're recording this meeting so that we can use it as a training tool in the future. So, Kempton, take it away.
Well, thank you, Dan. So we'll still stick with our usual approach of we'll take a look at the soaring models over the next few days, and then we'll talk about the bigger pictures too. Um, as many of you know, I used to use GG Weather, which I still occasionally use, but I've gotten off of that after having gotten more experience at Pivotal. So we'll get into that in a moment. But let's just take a look at the next 5 days based on SkySight, and then we'll go from there. So this is today, 2 o'clock. Looking all right, but kind of low. What's interesting, just looking out the window here at the strong overdevelopment to the north, lets us go to 5 o'clock, and you see, yes, we do have quite a bit of overdevelopment here. But I've noticed that, it's actually reasonably accurate SkySight for overdevelopment. But when you look at this versus what I'm looking out the window here, I mean, this overdevelopment is quite extensive. These seem to be separated here, but they're actually not. I mean, at least looking out the window here, they seem to have congealed into one big mass. So basically today, if you were flying, we had Russ Pollard and Pat Alford flying here, and Renee too, flying along the Mendoz. It was all right, 10,000 foot bases. Let's take a look at tomorrow. Okay, so tomorrow is showing overdevelopment here, which will likely have and also very strong overdevelopment over the Sierras. Now this is 3 o'clock. I'm going to just zoom in on Williams, since it doesn't look like too many people will be flying out of Minden and Tahoe, Truckee, simply because of this overdevelopment. If we look at 1 o'clock tomorrow, yeah, we have, what is this, 10,000 foot bases here, but it rapidly turns into, I'm just going to scroll forward, it rapidly expands into this solid overdevelopment here. So it looks like for tomorrow, Christian and I will probably just, we'll be making it up to Yola, and then we'll really have to be watching it so that we don't get caught in this stuff, and to be able to make it back. So basically Friday, if you're flying out of Williams, you may be able to get up to Yola. Out of Minden and Truckee, that could be problematic unless you leave early. But to me, there's not a lot to leave early for. Usually I'm only interested in a thunderstorm area because I want to use it to get out of there to get to the 18,000 foot kind of base places. But it doesn't look like we're going to have that tomorrow. And mostly that is because of our cutoff low. I mean, maybe you get 16,000, but you're not going to do a Jim Lee flight. Well, maybe if you get out here. I don't know if most of you know, back 4 days ago, Jim flew from Minden to Gillette, Wyoming, actually out here, which I believe was it was a declared goal. And I think it was something on the order of 840 miles, something like that. I don't know the exact number, but it was a hell of a flight. He did it in his EB-29, and it was like 9 hours. So, versus Drew's in my 12-hour flight, of which the first hour was just getting to the start point. So call it 11 hours, but he was really just zooming along here. So hopefully we can see if we can have him on to share that flight, because that was a spectacular flight. Anyway, but back to the local weather. So yeah, you could use it tomorrow, maybe if you want to get out and head out, into like Yellowstone or something like that along this line. But probably most of us aren't going to be doing that. Saturday, same kind of thing. We still have overdevelopment here. And so we'll be watching that. We're at Williams right now. We'll be flying out of here all 3 days. Again, for anyone in the Sierra Minden area, yeah, maybe you could get out of there. This is 3 o'clock and go over into the Yellowstone, central Wyoming area. But that's really all of that this is good for. Otherwise, it's just going to overdevelop and, obviously make things difficult for landing at Truckee or Minden. Sunday, the situation changes, and that's because the cutoff low leaves, and I'll dive into Pivotal here in a moment. But basically, it looks like Sundays we're returning to normal here at Williams, We'll zoom in here. I think we're going to see some, yeah, you have some Q up here. It's not that evident on SkySat. I think the Williams RASP, the Northern California RASP was a little bit more promising. I think there's going to be some Q here, but not much.
You show a typical points QT. That often is more revealing.
Okay, let's do that. So John suggests clicking on the point skew T, and we'll click here right around, Black Butte.
Yeah.
Yeah, looking pretty dry.
That's pretty darn dry.
Yeah, that spread there. So, yeah, maybe we'll just fly blue thermals up to here and get on Buckhorn for Sunday. Anyway, so that's the short-term outlook. Let's take a look at Pivotal to understand what's going on. So before we start diving into this, let's step back. Personally, I've been looking at the raw weather data since the late 90s, and I actually have screen captures from back then in order to understand, what's going into the factors that make up our soaring forecast. Back then, we didn't have anything. I think the RASP started only, Dr. Jack's RASP only started coming out in like 2000 or so. So to me, this is very similar to like, if you're a doctor to look at the, raw data from the blood sample, or if you're in finance to understand, what is actually happening with a country's imports, exports, or, what's the volume on a stock. I mean, you're diving into the technicals because it's easy to kind of take these top level statements from whether it's a soaring forecast or a stock market forecast or a medical, outlook on your life, but you still want to dive into the data just to understand, okay, is this really what is saying and what's backing this up? Okay. So that's kind of where I'm coming from on this. So this is Thursday at 4 o'clock, which is Friday 0 Zulu. So this, you can see here, just the 500 millibar, 18,000 feet. You can see how this is swirling like this in a counterclockwise fashion. That is a cutoff low. So now this is not as obvious as some other tools, but that's because we're zoomed in here. Let's go stretch out. This is one of the tools, so you can go to a national level. Okay. And now that cutoff low over here is much more apparent. Okay, I hope everyone can see that. I'll boost the zoom here a bit. So when you have this little whirlpool here, and you can tell this is only like maybe 200 or 300 miles across, these are called cutoff lows. And the reason they're called cutoff is because it's not part of a broad system. I don't see another broad system on here to point out, but they're essentially lightweight hurricanes, because a hurricane is a cutoff low. You got that swirling wind, but the moisture is really driving a hurricane. But we really don't get hurricanes out west, and besides, in the Pacific, they're called cyclones. And I don't think we've ever had a cyclone, at least in recent memory, out in California. But what we do have are these cutoff lows, and they can form either because a part of a large system from Alaska comes in and part of it breaks off. Other times it could just be because the confluence of a high and another low just makes this little whirlpool. These cutoff lows are exactly analogous. If you've ever stood by a relatively smooth flowing stream or river, that occasionally you just see these whirlpools happen right next to the shore. Why does that? Because the shore, right, is slowing down the water flow. And so you get this shear action, right? And then that can turn into a whirlpool. That's exactly what these cutoff lows are. It's kind of this result of these friction between these two systems. So that's the cutoff line. And the problem, as Dan alluded to, is that they are small, so they're easily pushed around by other larger systems. So usually you don't know that what their effect is going to be until maybe just 2 or 3 days beforehand. Many of you know I actually look forward to seeing cutoff lows during the winter, because oftentimes if they go over to Western Arizona or Las Vegas, if they're centered over Las Vegas, that's when you have the reverse flow over the Sierras. And then that's when we have the reverse wave on the Sierras. So when they happen in the summertime like this, then the result is these nice days. What I mean by that is 12 degrees lower than normal here at Williams. There's only going to be 90 degrees is the high over the next 3 days, but you can have cumulus on the Mendocinos. Okay, but let's dive, but that's enough on cutoff lows. So let's use pivotal here to try to understand what's happening. So first off, just visually, you can see the cutoff low here centered. It looks like around Big Sur, San Simeon area. Let's take a look at how this progresses. One of the things I like about pivotal is that the user interface, it's built for people like myself, and I'm sure other weather professionals, to toggle back and forth between different runs and what they show. So these up here on the upper left, weather model runs are usually run every 6 hours. Now this is the European model here. If I click on this, we can go through different types of models. Look at all these models. I mean, you know, there's way more than I thought that there ever were. So Pivotal, they have plugged into every model out there. There's a Canadian model, there's the Australian model, there's the American model, there's the European model, the UK model, all kinds of stuff. But really, the only two we care about are the European model, the ECMWF, and the American GFS. SkySight is modeled using primarily the data from the European model, this one. And so I click on that, and so everything we're going to see is a result of that model. You talk to a lot of meteorologists, they generally see that the European model has a slight edge on the American GFS model in terms of accuracy, you know, like 4 to 5 days out. Once you get within 3 to 4 days out, they usually track each other fairly closely. But when you want to go a little further out, that's when they deviate. Okay, so that's why we're looking. And I've come around. I was a GFS guy for a long time, and I finally got convinced that the European model is the way to go. So I'll pause there. Any questions, comments so far?
So
No?
the cutoff flow is when I look at that picture, it's a circulation of dry air or moist air, because it looks like it's both, right? We have some moist air closer to the center, then dry, then moist again at the edges. Is that always like that, or?
So that's a good question. Just this particular one. So because I'm looking at the relative humidity, so I didn't finish going through the rest of the pivotal model here. So you have your model runs over here, you have the model type itself here, you have the geographic coverage here, and then now you start going down here to find out whatever it is you're interested in. Is it the rain? Is it the temperature, surface temperature? Is it the upper air moisture? Usually we're concerned with the upper air moisture. And so we're looking at the 500 millibar here, so that's 18,000 feet. And so the question Rami brings up is, are we looking at, is this fairly wet? Well, it's actually not. So it's like, if I hover my cursor over this, you can see in this curling in plume, it only gets to about 35%, 40% relative humidity. My experience is on the Mendocinos and Central Valley, you need like, 60% relative humidity like this green, 40 gets up to 73% there. You need about 65% to get cloud. Out in the desert, meaning Nevada and along the Sierra, it's lower. You only need.
What? I have my earphones on. What? Huh?
Oh, sorry. If you could mute, thank you. So out in the desert, you only need like maybe 35% relative humidity. I mean, if it's really hot, then maybe you only need 25% humidity out in the desert. So to answer your question, Rami, so this is pretty dry. I mean, because there's only 40% here. Like I mentioned earlier, a hurricane is a cutoff low, and that, of course, because those are out over the Atlantic, and the Atlantic and the Gulf are very warm, so there's all this rich, humid air. What do we have on our West Coast? We have dry, cold air from Alaska. And you say, but Kempton, we get fog. That's absolutely right, because that is this very thin layer right next to this cold water, and it's only like, usually 500 feet deep, versus a hurricane, which is sucking up all this 80-degree or warmer air, humid air right off of the Gulf of Mexico. So to answer your question, this is dry. And I've never seen a wet well, excuse me, I shouldn't say that. Those do happen during the winter time, but it's not because of the surface relative wet air. It's because that moist, unstable air came down from Alaska. But usually they're dry.
So what's
Kempton?
drawing all the moist air into the Sierras and into Sinos then?
Correct.
that case.
That's what you're seeing here.
Yes.
Although the center of this whirlpool, if you will, is here, it influences things around it, including the Sierras here and including as far up as Northern California. And the way we can look at that, again, this is what's cool about this. We keep the same view, the same time frame, but now let's click on just the height and wind. And you can see this arc here. It's not strong, again, it's not a hurricane, but you can see that it's influencing to about Northern California. So it is not influencing up to Oregon. So John, you had a question?
A little bit similar to Rami's. You're saying it's dry, but then the QTs, at least for Saturday along the Mendocinos, had from 8,000 feet to 20,000 feet. It looked, the temperature and dew point were right on each other.
Right.
On the other hand, the Williams rasp looked very nice there for here, so I couldn't figure out what the hell's going to go on.
Right. So those are two subtle differences there, because although this cutoff low is indeed it in itself is dry, the fact that it's reducing the pressure just a little bit. In fact, let's just bring up, it's not very much at all. So normally at 700 millibars, the normal pressure around Northern California is around 318, 319. And now it's like 315. It's a tiny difference, but that difference is enough, right? If you lower pressure, that means the air can't hold as much moisture. And so therefore the relative humidity goes up. It's not gone up much, maybe like 10%, but that 10% is enough to flip it into a both more unstable situation and of course having more moisture to generate cloud. Excuse me, having less, not more moisture, but it takes less lifting to make the moisture happen or make the condensation happen. Okay.
Kempton,
Yes.
question on models. The GFS is 22 kilometers resolution. European, I think, is 7 kilometers. There's an HRRR, which is 3 kilometers, which
Right.
for local soaring would imply better granularity in terms of Three Sisters versus Walker Ridge, etc. Do you have any thoughts on that subject? It's available both in Pivotal and in
Right.
SkySight.
So John's question is, there's the HRR, which has a lot better resolution. Why aren't we using that? Well, it depends on what you're after, right? What's that old saying? You can have it fast, cheap, or good, but you can't have all three. And that's exactly the same thing in weather forecasting. You can have it more accurate, but it won't go out very far. You can have it finer resolution, but it also won't go out very far. You can have it lower resolution, but have it go further out in time. But you can't have fine grain, high resolution, accuracy that goes out 2 weeks. That's just way too much computation. So that's what HRR is only for, like the near term, which I believe is it goes up to a max of 48 hours. So it depends on what you're after. If you're, the time I use HRR most is when I'm doing a reverse wave flight. So I'm extremely interested in these very small macro changes along the Sierras. And so that's when I use it the most. But when I'm actually trying to figure out when a certain setup is going to happen, then I'm fine with GFS, because that goes out 360 hours, which is what, 16 days or so. So it depends on what you're after. It's, like any tool, right? What am I trying to do? Am I trying to, basically have a nuclear bomb and wipe out lots of people and buildings? Or am I looking for a sniper rifle to be able to take out one target? It just depends on what you're trying to do.
Thank you.
Okay. So, and like, in most of those cases, you take this macro picture. Let's go back to the European model. You take the macro picture and it's like, okay, what's happening on a larger scale? Well, this cutoff low is a larger scale thing. Okay. So let's throw some soaring at this, going, okay, fine. We have this cutoff low, but I want to understand, how is this going to affect the soaring and how long is it going to be around? So this cutoff low is here. It's probably better to see on the 500 millibar. Yeah, it's easier to see here. Okay. So let's go for, this is this afternoon, Thursday, 4 o'clock. Let's go to tomorrow, 24 hours later, Friday, 4 o'clock. Okay. Now you see the center of this has moved north. This is why the forecast for tomorrow, which really didn't have that much overdevelopment on the Sierra, on the Mendocinos, is now much more overdevelopment. Why? Because the center of this low has moved north. So this minor movement of what, 150 miles for that center greatly makes a difference for Friday. That's what's making all this and all this. Okay. Because again, it's a very, it doesn't require, you don't need much drop in the pressure for the air to have that much less capability to hold the moisture before it condenses. Okay. And that's why this has turned pretty green. One of the nice things about Pivotal, because of this user interface, I go, how much has this forecast changed in the last 12 hours? Okay. This is the latest one. Actually, this is the latest one. Okay. But it doesn't go out as far. Okay. So this is for Friday at 4 o'clock. Look at how dense green that is. That's, I'm seeing 88% there. How was this forecast 24 hours ago? So let's go to Wednesday at 18. And look at that. I mean, notice how this is not nearly as green. I mean, I'm only getting 70 to 75% peak versus the 80 to 83% peak. So that's what kicked up the overdevelopment. It doesn't take much in increase in relative humidity for that to suddenly explode. So for those of you who know your chemistry and physics, why is that? Because when you start having a little bit more moisture, right, when you go from water vapor and it starts making those droplets, it releases heat. And so that tends to make things, what's it called, a runaway engine, a runaway heat engine. That's why you get thunderstorms and down in the south, when they start sucking in more moist air, it just feeds the thunderstorm, makes it bigger, faster. Same thing here. It's going to make these storms here bigger and faster because even though it only increased by 10% relative humidity, that's an enormous injection of more condensed water vapor.
So what's your threshold for Q versus overdevelopment as far as relative humidity?
So that's a good question. What's a threshold for Q? I mentioned that I've noticed it's around 60% here to get cumulus. Well, we're seeing, 70, 75%, even spots of 80% from the forecast 24 hours ago. If we go to the current forecast, you look at this area, it's even much darker. Okay. So Rami's question was, what's the threshold for when it goes to overdevelopment? And the answer is it varies. And that's because you've got several factors. There could be a what do you call it? A mild inversion aloft, to be able to suppress that. There could be drier air aloft, which then would suppress it. Or there could be cirrus aloft, right? So it's not just relative humidity in this case. Now, I'll just take a look at the cirrus just to take that out of the equation. Oh, well, we're not going to take it out of the equation. So there's actually a fair amount of cirrus tomorrow too, but that's likely from the
Blow up.
And so the way we can tell that is let's go 3 hours beforehand. How does it look? Oh, it looks a lot less. And it also has that streaky look. When it's streaking like that, that's not from overdevelopment. When you see these spots here, like in northern New Mexico, that's from overdevelopment because that's a thunderhead. And the way I can validate that is I'll go even 3 hours before that. Sorry, clicked on the wrong model. Come on. Okay. So you see none of that little splotchiness down here. This is at 10 o'clock in the morning for New Mexico tomorrow. If I just go forward just 3 hours, see the splotchiness is showing up? That's the top of a thunderhead. And to further validate that, you can then click on surface precipitation. That's basically rain. Okay. What about the rain? Well, look at that. There's rain. Remember, rain is the ultimate result of overdevelopment. Excuse me. You can have overdevelopment but not have rain. You can have virga, right, a little bit coming out the bottom, or you can have, like we have in central Nevada, you can have these towering cumulus and they're just about to dump out, but they don't quite. And to me, that's the Goldilocks situation, but that rarely happens because it has to stay like that. You know, usually it doesn't stay, it just keeps on going. So whenever you see these spots of rain, that's the confirming validation that you got thunderstorms. Okay. Now, again, this is summertime. If you see rain during the wintertime, it's usually more in this like curved pattern from a front coming through. So that's different. So to answer your question, Rami, it basically just depends. There isn't, I've noticed it, you can have over generally, but I will generalize that around 60 to 70, 65 to 70% on the Mendocinos and maybe 40% during the summertime out in Nevada. You know, that almost certainly will result in overdevelopment. Okay, so, but you see the nice thing about this user interface is that you have the same times here, and I can toggle between models, and I can toggle between timeframes, and I can toggle between the data, like we just did here between rain and cirrus. It's 300, to technical term, it's 300 millibars, 30,000 feet moisture, but I just call it the cirrus indicator because that's, you know, what, if you're going to get precipitation up there, it's cirrus. Okay. And then over here, we see, again, this is tomorrow, 1 o'clock. Here's all this cirrus from the overdevelopment on the Sierras and the Mendocinos. Let's go 3 hours more, and there's going to be even more. Yep. So basically, it's kind of a wipeout out here. But let's go back and zoom in, because a lot of times I have the question, I go, okay, oops, sorry, regional. I go, well, yeah, I see cirrus, but how thick is it? Because if it's just, you know, thin, then maybe there's enough sunlight to get through. So let's click on at any point. Ooh, 101%. I've never seen over 100%. Let's see what that shows. Okay, so what it shows when the temperature and the dew point get together, that's when you have condensation. And right now it's showing solid condensation between 300 and 350 millibars. Well, that's like from 30,000 to like 36,000 feet. That's a pretty thick cirrus later. So we're talking some serious cirrus tomorrow up in that area. And then you go, okay, well, let's just go like further south on the Mendocinos. Let's click right there. Is it still pretty thick? Yeah, it's still looking pretty thick. So basically, this is telling me from a soaring standpoint, I'm going, well, again, this is 4 o'clock tomorrow. Let's just say we launch at noon. This is the 1 o'clock. You know, we're only going to get up to about here, Christian and I, before we go, you know, this is looking pretty overdeveloped. So we're just going to basically, my guess, that's around probably Black Butte. And that's all we're going to get, which is okay. You know, it'll give him a good view into, you know, why us crazy soaring pilots want to get sort of close to thunderstorms.
Hey, Kempton, you might look south. So I was out doing some power plane stuff today, and there was a spectacular convergence line running from Livermore to as far south as I could see.
Let's take a look at that. So John's saying, is this for tomorrow?
This was for today.
Oh, for today, okay.
Yeah, the next few days looking pretty good for Hollister area.
Yeah.
And that
it was
makes
actually
sense. Oh, yeah, like that?
Yeah, it was a lot better than that. It was actually down the middle of the mountains due south of Livermore.
Yeah, I mean, that's the usual convergence, which zone for Hollister and Byron. Right over the San Antonio Valley, there was a lot of queue today. I could see them.
Yeah, I could see them too.
Bay 1000. You look in convergence, but I think best is to look at clouds.
Okay.
That that's what I look. But I don't know.
Yeah.
SkySight. So we already know that SkySight, true for Williams as well, doesn't always detect the convergent Q so well, right? So,
I'd
but
agree with
you're
that.
at 6 o'clock. Maybe look at 3 o'clock, kind of.
Or maybe the height of the lift would tell you.
You see only the one further south, but they were also
Yeah.
further north. But the RASP show it very well. I go by the RASP for the
Sure.
cues for the especially from flying from Byron and Hollister. So you can click on the Byron one and you see the cue. So that's exactly what
Well,
was
this is tomorrow, but yeah.
okay, we lost Thursday already, but it looks similar earlier.
Right. So
today.
I would agree that, based especially when a cutoff low comes over, it actually favors, because of this overdevelopment possibility, actually favors lower ground, but you want to have a little bit of at least hills or something. And so that basically favors Hollister tomorrow, because as we're seeing here. So what is that? 8,009 from 7 to 9,000. That's pretty good,
It's pretty good for Friday. I think Saturday and
Yeah.
Sunday. I don't know about
Take a look at
Sunday, but I think
Saturday.
Saturday also. That's still showing. That's still showing Friday, so it's
Yeah,
it's still cached on your computer.
Hasn't switched. So let's redo this. All right. It still hasn't done it yet. Well, actually, let's look at the older forecast. Yeah, Saturday's looking dry, but this is the older forecast. Let's take a look at the NorCal. See if that Saturday. Come on. Friday. Not showing. No, it's showing some. This is for tomorrow. Fairly, what is that? 8,000 feet. Okay, but that's further down the range. Let's take a look at 4 o'clock. No, it's kind of like it's going to start later. Whoops, it's going to start later, but it definitely, oh, come on. It starts later, but it looks pretty good. Saturday. That's Friday. That's tomorrow, and 4 o'clock. Wow, that is a nice line. That's 4 o'clock. Let's look at 5 o'clock. 6 o'clock. Yeah, so basically late starting tomorrow, but you could run and you still would have stuff around Coalinga at what, 8,000 feet or so.
It's
So
almost always better than that RASP showing. So if the RASP showing that picture, I mean this RASP, the NorCal RASP, then it will be full of clouds.
Oh, that's great. Yeah, no.
Yeah, it's really looking good for Hollister, I think, tomorrow, and
Let's take a
we'll
look.
see what Saturday will say. But
looking pretty dry on Saturday. But again, this is influenced by the cutoff low. So let's go back and see. So this is tomorrow, 1 o'clock. Basically, so okay, Kempton, you've told us about it's here. When does it leave? So this is Friday. Got all that cirrus. Let's look at Saturday, same time. This is again the 300 millibar. Let's go down to 500. It's kind of fell apart. You can see a little bit of curl here, but it's not much. So Saturday, looking all right. Let's see what 700 millibars said. A lot less humidity, 60, 65%, maybe 70%. But again, the acid test is rain. Let's just see, is it actually going to say that there's any rain? And there's just a little bit. When you see these tiny spots of gray, to me, that's the best. It's just like it's just starting to, do a little bit of precipitation. It's not this green stuff over here and, wiping out large areas. So actually, based on this, the 12 o'clock run. Let's take a look at the even.
This is for Sunday, right?
This is for Saturday. So the latest run went back to showing more rain. So to me, I blame this on the wobbling of the cutoff low, which I think is Saturday. Let's go down to the moisture. Let's take a look at that. Yeah, there's still a little bit of curling here, but it's not as strong as it was. So basically, Saturday is when the cutoff low starts falling apart and fading, and that's still what, 36 hours, 48 hours away. And so for Williams, at least, this outlook on SkySight for Saturday, we'll just see. I mean, I think based on this, I think there'll be some overdevelopment, but it won't be as negative looking as this is.
Yeah, the point skew T's on SkySight look just awful for Saturday.
Right, but again, to me, because that's 2 days away, I'm not,
So there's a chance.
Yeah, well, and to me, all weather forecasting for us soaring pilots the reason we use it is for two reasons. Do I go up to the glider port at all? And then once I'm here, I have sunk costs because I'm already here and I'm already here.
Right.
And so then the second reason for weather forecast is, okay, where am I going to go and when am I going to go? Right.
Well, Saturday does look, it's been jumping around.
Yeah, it has been. And
you take a risk. It looks like possible that it would disappear. Sometimes it's not possible.
Yeah, it might. But I guess, for me, I'm already committed to this time.
Yeah.
So I'm not concerned as much because, we'll work it. And for my goal to introduce Christian to soaring and reading clouds and maybe a little bit of overdevelopment, this is actually going to be just great. Just don't get sucked up and don't land out. Those are my goals.
Now I'm curious. I'm curious about Sunday out of Truckee.
Okay, let's take a look at Sunday.
Maybe Rami's curious about that too. I don't know what other
So
people.
let's go to Sunday. This is the one that showed nothing on the Mendocinos, at least for me.
But northeast out of Truckee looked like a fun project Sunday.
It's low 12, but at least it's not overdeveloped, at least at 3 o'clock. And if we look at Sunday's forecast, which for 500 millibar, which is more relevant for the cirrus, it's looking pretty dry. And then we look at 11,000 feet. Yeah, it's still pretty moist along here for Sunday. So this is this is completely different than this.
Yes.
So yeah. So basically the professional weatherman's statement at this point is, we'll see. Yeah. Taking off. Okay. See you, Charlie. So yeah, I mean, let's as a contrast, let's look at the previous forecast. Look at how moist it is along the Sierra Mendocino. It's like 80-90%, but it's dry along the Sierras. So if we go to previous forecast, and it's looking kind of the same. So the reason, for those of you, the reason I toggle back and forth a lot is this is the way I judge how much do I trust these forecasts. If they're jumping all over the place, I go, who knows? But if it's been consistent, and I use the same approach when I'm looking, 10, 9, 8 days out going, the heating and the relative humidity and the cirrus are all staying pretty stable. Like the flight I did from Las Cruces to Reno, 5-6 days before we did that flight, even 7 days out, it was staying very similar. And that's what gave me the confidence to say, okay, yep, I have high confidence that setup when I have to commit resources and, take the time to get out there, that it's going to happen. So that's why you toggle back and forth between these different data sets is to give you confidence. Does that make sense? Okay. Other questions? Okay. So that wasn't exactly your textbook approach to using Pivotal, but I always think it's better to, have a specific use case and a specific reason to do that. So pretty much I just use the most of my time I spent on upper level air moisture. I mean, obviously during thermal season. During the wave season, I spend most of my time here on the upper air winds. Okay. Like this. This is during the wave season. But the same approach applies. I toggle back and forth between models. You know, I look to see, well, how do the winds at 300 millibars versus 500 versus 700, ideally for wave, you all want to see them going, you know, about the same direction, plus or minus 10 degrees. Okay. But, you know, when we move into wave season, we'll exercise that. Right now we're in thermal and cumulus season. So we'll spend our time, you know, looking at 500 and 700.
So
Okay.
Kempton, sometimes you you were just talking about planning resources, you know, committing resources and looking out into the future.
Yep.
Give us an example of looking out into the future, and let's say for the Truckee Task area, if you were just to scoot out 3, 4, 5, 6, 7, or whatever days,
Okay.
how's that? Just explain to us what you're seeing there.
Sure. Okay. So let's just say that. Say I'm looking to spend a week up at Truckee. How do the next 2 weeks look? Okay. So that's a very legitimate and common question. Okay. So here's Sunday. Along the Sierras, and now if you want to go basically north, south, or east from Truckee, Sunday, not much moisture out there, and there's a fairly strong south wind. It was Sunday. Monday, you can go down to the Whites and back. That's about all you can do. Tuesday, okay, now we got more moisture, but all of a sudden it becomes this 80 to 90% stuff. So now it went from, you know, nice to all of a sudden, you know, way too much moisture. And look at this. This looks like another cutoff low forming over here. We'll have to watch that. Okay. So let's go out to, that's Tuesday. So then 156 is Wednesday. Yeah, still got that moisture, but you can't go very far, you know, because it goes up to what, Haralong, and maybe down south to Bishop, you know, and that's it. That cutoff low is kind of pretty much fallen out of the picture. Let's go to the next day. That's Thursday. Similar. Let's go to Friday. Similar. It's been a continuous south flow too. You know, you may be able to get out to Hawthorne, down to the north end of the Whites. You know, that's about it. Let's keep on going. This is Saturday. Oh, even dries out even more. 252. Now we're 11 days out. So you have to watch that, you know, because you're this far out, you know, that your confidence in this is less, and it's even drier. You know, it's basically up to this point. If I had to make a call right now, I'd say, okay, if I wanted to do some local soaring out of Truckee, go for no further than Hawthorne and north end of the Whites and back, maybe with one thunderstorm day in there, you could do that. You want to do 1,000 kilometer or, you know, do a 1250 straight out, forget it. That's how I read this.
Thanks, Kempton.
Okay.
But that's not exactly what SkySight's showing.
Well, but we've gone beyond SkySight. So I was
No, I mean for the first part. For
Right.
the SkySight, I think goes up to Monday or Tuesday.
Right. And that's actually that's a very good point. It's kind of like, this data seems to be different than what SkySight's doing. So go, okay, well, you know, then I shouldn't, you know, if I'm already going up there for other reasons, you know, okay. But the fact that the moisture models are much drier than what SkySight's showing, you know, like out here, 15%. I mean, out here, you know, 40%. The white color will be good for cumulus out in the desert during the summertime in Nevada. But anything less than that, you got 15%, you know, 14%, you're not going to get cumulus.
Yeah, but that's 2 weeks away. I'm talking about the next few days.
Okay. Yeah.
What it showed earlier, I think it showed more moisture.
Oh, it is. And this is Friday. Well, actually, no, let's go to the.
No, that's no point to look before Sunday because it's too much moisture until then. So we already.
Right. So this is Saturday. Yep. There's too much moisture out there. This is Sunday. It's drying out a bit, you know, but Again, it's one of these it's one of these situations where you got these pools of moisture with 50, 60%. And as soon as you go outside of that, you got 30 or 20%. So you've got either overdevelopment here and then nothing out here. So that's Sunday. Let's take a look at Monday.
With
I thought,
Sky-
what did we say the threshold you said for the desert? I thought you said was what, 40% or so
No,
for
out in the
Q?
desert, it's around 30%.
Okay, so that looks good then.
Right. And
But that's Monday.
yeah, this is Monday.
Sunday, SkySight's saying Q everywhere, and you're saying it's pretty
Yeah.
damn dry.
So Monday, well, let's contrast this with SkySight. We got the white, to me, white slightly moving into the green is probably good for some nice cumulus that don't blow up. Let's take a look at Monday. Okay, and it's showing it's pretty sparse out there versus it, yeah, it's pretty, what time is this? That's 3 o'clock. Okay. What is this? This is Northern Nevada, and on this, it's a mix up here. So I would attribute this just basically the small variance of maybe 5 or 6% in the moisture can make a huge difference, especially out in the desert for cloud. But generally, it's around 30% what I've noticed out here. If it's at all typical temperatures, meaning, what, 85 degrees at Tonopah kind of thing.
Yeah, but for the Sierras and the whites, it looks pretty good.
Yes,
Okay.
50%. So, and how does Monday look on the whites and Sierras? Yes.
And Sunday?
Let's go back
Monday.
to Sunday. This is Sunday. So you have this broad area of clouds, but they're low, 12,000 feet. And if we look at the Sunday back here, it's not, oh, so in this case, I'm going, yeah, I look at that, but because the cloud base is so low and the cutoff low had just passed, let's look at the heating.
Mm.
Yeah, I mean, more typically you see a bit of this white. So this is a bit on the cool side, but you would expect that because the cutoff low had just kind of passed this way. So, so to me, this is where we're reaching the limits on when you look at the individual data points, because weather's complex, you can't just pick one, right? You can't just pick the moisture. It's the
Yeah.
moisture and the heating. And so that to me, this is where SkySight, of course, does its best because it's synthesizing all that. Now, the fact that it missed the cirrus a week ago, we talked about how SkySight missed the cirrus, that happens. So to me, it's not like we're trying to be better than SkySight. To me, it's more like we're just trying to understand, what other factors are going on that we might just have to consider. So that was just a broad statement for everyone. I'm not trying to be better than SkySight. I'm just looking to see, okay, yeah, it looks interesting, but what's going into that?
Yeah, and you got to understand the mechanism to know if you believe it or why it might change.
Right. And that's a very good point, John. It's also the trends too. Like if you see it's a great day, but a front is coming in because we know in wave situations, and also I've noticed in great heating situations out in the Great Basin, right? You got these great days, 18,000 foot bases or plus, but there's a front coming in, and that front, the timing of that front, if it comes in, basically before the end of your soaring day, no problem. But if it starts coming in like in the mid-afternoon, then you got problems, right? If you're trying to do like a big triangle or something like that. So this is also where this is helpful. It's kind of like, okay, SkySight's saying it's going to come in at this time, but Pivotal says it's going to come in at this time, right? And so that's where you factor that into your flight planning going, well, if I have to cut it short, I'm going to be looking for that cirrus, which is, indicative of the incoming front, or, like we've seen in the springtime, like on a wave flight, like the wall of water coming towards you to be able to time that. Any other questions or comments?
Well, Kempton, you said on Tuesday in Pivotal, it looks like it's gonna OD down the Sierras, but I think SkySight may or may not be showing that for
Okay,
the
so let's
different.
take a look at this is Sunday, so let's go to Tuesday and let's actually just look at the rain. Yeah, a little bit. I mean, to me, anything under anything of 5/100ths or less, that'll be, you have to watch for it, but it's not going to be, when you see these green ones, I don't see the scale here. I don't know what green is. What's green? It's 2/10, 3/10. That's serious rain, right? But these slightly little bits of gray shouldn't be a problem, right? In other words, you can go around the front of those as opposed to having this being kind of a wiping out an area.
And if you jump to the SkySight app and look at the rain calling on SkySight for Tuesday.
Yeah, nothing. But again, this is older. What was this? This is oh no, this is fairly recent. This is 8/24. This just ran. That's interesting. So, well, right, but it wasn't off of this data. It probably ran off of the 12 Zulu data. And what does that show? That shows nothing. Okay. Although it shows
Tuesday is now spectacular on SkySight, where I wish I wasn't doing stuff. Tuesday is, look at the Q cloud base. Everybody quit your
yeah,
jobs.
17, 18 out here. Yeah, that looks good. So to me, even though this run, the latest run, shows a little bit more, it's not much. I mean, like I said, it's 3/100ths, 1/100th, 7/100ths. To me, that's within the variance of that's within error.
And would both of those models be showing high cirrus?
Let's take a look.
Because that's easy to pick out.
Yeah, so 300 millibar for cirrus. There could be some here. Okay, but how deep is that? But again, this is the latest model. If we go to the previous one, which is probably what the SkySight run was off of, well, it's showing some cirrus. Let's just see what SkySight says. High level cloud. A little bit. So to me, this is consistent. It's showing a little bit on the 12 Zulu. Let's click on this to probe into that. That looks fairly thin. And indeed it is. It's just a point meet. Okay, so that's consistent there. And so when it meets like that, usually, I mean, that I'm not too concerned about that. It's when it's, 300 to 350 millibars deep. That's thick cirrus.
Thanks for walking us through that.
All right. Well, everybody enjoy the flying, and if you have any questions on Pivotal, happy to answer that. And I'm just thinking, I could probably post some of that to, probably to the WhatsApp group, maybe. I don't know. I'll respond one-on-one until it gets to be too much volume.
Thanks, Kempton.
Okay.